Hello, good morning, and good afternoon, depending on where you are in the world. This is David Leichner. I'm the CMO of SQream Technologies. It's wonderful to see all of you with us online today. This is actually one of the biggest turnouts that we've ever had for a webinar to date. And I guess it's no surprise given the topic of today's briefing. So just a couple of housekeeping notes. First off, if you could please raise your hands to show me that you can hear me. Great, excellent. So I see that you can hear me. That's wonderful. Second, we'll be taking questions at the end of today's session. So if you have a question, you should be able to see the question panel on your GoToWebinar control panel. Please send your questions through that panel, and we'll take those questions at the end of the session. Okay? So let's get started. So we are very honored today to have with us Tim Jennings from Citihub. Tim is part of Citihub's consulting business transformation practice, and he will be discussing with us today Citihub's findings from their recent white paper, GPU Accelerated Databases, addressing FRTB risk results reporting and other performance at scale challenges in financial services. So before I hand over to Tim, I'd like to just say a couple of words about SQream. SQream develops and markets SQreamDB, a GPU database designed to enable unparalleled business intelligence from massive data stores. Global enterprises are using SQream to analyze more data than ever before while achieving improved performance, reduced footprint, significant cost savings, and the ability to scale the amount of data they analyze from terabytes to petabytes and more. SQreamDB is available both on-premise and in the cloud. Now I will hand off to Tim, who will give you an introduction about himself and Citihub, and then take you through the presentation. Tim, please.
Great, thank you, David, and thank you everyone for making the time to join us today. Okay, my name is Tim Jennings. I work for Citihub Consulting. David, if you can go to the next slide, that'd be good. Thank you. What we're going to talk about today, I shall introduce you briefly to Citihub and to myself, and then we'll talk about some of the performance at scale challenges within the big investment banks. So we're going to go in some 10,000 foot view through what the banks are doing and why they're being challenged, and we will look then at what our idea was for how GPU databases could potentially help them to meet some of those challenges. We'll go through the testing that we ran and the results from that, and the conclusions and further analysis. So hopefully at the end of that, you'll have some insight into the work we did and the types of challenges which are present here within the investment banking community, and which I suspect will be familiar in other business verticals as well. So hopefully there'll be some insight there, which is going to prove useful to you. David, next slide. Thank you. Okay, so first of all, let's talk about Citihub very briefly. So we're obviously an IT consultancy and predominantly working in financial services. 8 of the top 10 tier 1 investment banks are our clients to date. We've got others, sort of tier 2, tier 3s. Been running for 20 years now in the financial services business. We don't work only in financial services. We do tend to focus on real-time and mission-critical applications. So obviously that lends itself very nicely to financial services, but it also means that we've been able to do work in airlines, in some of the gaming industries, where similarly they've got real-time challenges and mission-critical challenges to meet, and the skills are pretty portable. So we do venture outside of financial services as well. Offices are based in London, New York, Asia, Toronto, and so on. And mostly we are experienced practitioners. So most of the people you'll come across from Citihub have got 20+ years of IT and investment banking experience, typically. And importantly for this conversation, we are vendor agnostic and independent. So we don't, we help our clients make choices about what technologies to buy. We're not bound to any particular vendor. So that's Citihub. very briefly introduce myself. The white paper that we've recently published, which you'll find on our website, was co-authored by myself and my colleague Kieran Bradley. I've been with Citihub since 2009. I've got 20 odd years in financial services. I've also got some years in energy and in government. More recently, my focus has been on business development and business transformation. So discovery and understanding of what the businesses need and how they're making their money, how to implement new platforms, business transformation roles, and tasks and deliveries within that scope. So generally helping the businesses to move forward and improve how they're operating. Okay, sorry, I've got to, can we go to the next slide, please? And again, next slide. And the next slide, we've done all of those. Thank you. Okay, so let's talk about the problem statement. To frame what we did and hopefully to engage your sort of technology interest early, the particular piece of work we've done is around taking an investment banking data set at various different scales and throwing that at a set of different technologies with a set of predefined queries to understand how they perform relative to each other. So we had GPU technology in there in the form of Kinetica, in the form of MapD, in the form of SQream. We had some non-GPU technologies, Google's BigQuery, a cloud-based database, and SAP IQ, which is a 20-year-old or 20-year-long history, industrial strength, traditional database. And the intention was to compare these sort of traditional understood products with some of the new things that are coming up, to understand the raw performance, not looking at the scalability, but how one box would perform with these data sets, and to leave largely out of scope for this operation, the sort of performance operation, the performance optimization and that kind of stuff. So we were taking databases and we were seeing how they would solve the problems that we see in financial services. So let's take a look then at, and perhaps we can go to the next slide, at what those problems are. Let's start by taking a step back and looking at the issues that are facing the big investment banks. The focus of our conversation and our work is around market risk management for investment banking. Market risk is a reasonably simple concept to understand. We're all familiar with it. Market risk on a personal level is the risk that you have when you have a floating rate mortgage or when you have stocks and shares. You know that the interest rates can change and your mortgage will go up or go down. You know that your stocks and shares value will change and that the value of your asset will go up and down. That's market risk. The banks, of course, have that problem multiplied 100,000 times because they've got so many different transactions with different clients. So their job, there's a common misconception that investment banks make money by guessing which way that's going to go, guessing that one stock will go up or another go down, or that interest rates will do one thing or another. That's not how they make their money. The investment banks make their money by charging fees to sell and buy this risk off their clients, so that they make their clients' lives less risky by taking that risk on themselves, and then they have to hedge it. Then they've got to sell the risk away so that the bank itself is not overly exposed. That's the fundamental job of a trading desk. The problem that the banks face today, if we look at the diagram that's on the screen now, is that risk is managed at a detailed level within each asset class. An asset class being, for example, an equities desk, an equities derivatives desk, a FX desk, or a rates desk, or a fixed income desk, or whatever. And they tend to have different applications per asset class to do that. Those have grown up over time. They're specialists for the asset classes they're working in. They generate an enormous amount of data, and it's all locked up at that. What you can see on here is the front office level of risk and valuation, where that top red box is. That's where the risk is captured and managed. But typically once a day, that data is also fed down to a market risk control function, the lower red box. And it's their group, their job rather, to manage the group level risk. So their job is to report to the regulator what the risk is, to manage the capital adequacy, to make sure that the bank isn't overexposed, isn't going to go bust because of the risk it's taken, and to do that across all of the different asset classes that are coming in. Now, the challenge for them is that the data's coming in once a day. It's aggregated, so these are typically cubes, but they're not. They can't scale to being able to support the level of detail that each one of those asset classes is able to support. So they get aggregated data. It's too big for them to store any kind of history there. So they can, a day or two at best. Performance is generally shocking, and changing that platform has a very long lead time. So you end up with the front office teams, the teams who are reacting to the market, the teams who want to be able to make money and be nimble, being held back by the performance of the risk aggregation level, sort of way down in the control functions, because they can't keep up with changes because their technology is too slow and too big and too difficult to move. That's already bad enough. And then it's been made worse. It's been made worse for the banks by regulatory change, which is forcing a commonality across those different asset classes. So where we see, across the top there, in intraday business, an equities business, or a credit business, or whatever, what the regulators are beginning to insist on is real-time data being fed through to them, and that everything is managed in the same way. So that set of parallel systems is no longer an acceptable answer. And so this is driving them towards building bigger and bigger risk sets up in the front office, so bigger risk sets up in the front office, and they can't pass those down to the current cubes because they don't scale. They're all pre-computed, which limits what you can query, and they're hard to change, as I said earlier. Okay, next slide, please. Okay, so this is actually one of the slides of the results of our queries. So we understand the problem. Okay, so we've got a business which is trying to be nimble and trying to be agile. It's being held back by its risk reporting framework, which can't possibly respond to that. And the question we posed ourselves was, can the GPU databases help us here? What would we like them to do? What would be good in this scenario? What would free up the business in both cases to work better for them, to be more agile? And we see two distinct different problems here. One is about speed, and it's about those cubes, and it's about what the risk control functions and the traders are seeing. There's a cottage industry today in tying back those two different sets of numbers. So all the aggregates go into one system. Those are then queried, and people spend their lives practically working out what went into those numbers, where they came from. Wouldn't it be awesome if they could actually work off the same set of data? Wouldn't it be awesome if they had all the detail there and not the aggregates, so that when they wanted to know where did that number come from, they could click and see it? That would be fantastic. That would be life-changing for the risk control groups. Similarly, for the front office, at the moment, the risk control groups are generating their own metrics, which are used to report to the regulators and so on, but they can't be seen by front office because they're in different systems. They're coming off that system down in the operations world. So the front office can't control it. They can't manage that risk. They're managing the market risk they can see, but they're not managing the way it's calculated and presented to the regulator. Wouldn't it be awesome if they had a common set of data, so they could see those numbers? They could see what went into them. They can see what the risk control functions are doing with their data. That would be fantastic. Suddenly, those two functions could work much more cleanly together. That would be, life-changing again for the front office. And then we talked about the parallel systems up at the top, and here we get a big data problem. As I said, each one of those is creating huge volumes of data, and currently there isn't a bank that I've been to yet which puts all that data together in a non-aggregated way and allows you to do detailed data science on that. There's a huge asset there in terms of the data, which is simply going to waste because they haven't got the technology to put it together, to knit it together. If you can do that, then you get the possibility of doing correlations and cross-asset analysis. So when rates go up, what happens over here? Can we do that at a detailed level? Can we see exactly what's happening? Can we see trends? Can we track behaviors? I mean, think about rogue trading. Or think about the LIBOR scandal, for example. Can you begin to see where that sort of activity is happening in different asset classes, and track what's going on, be more aware of what's going on? And when you get that sort of data together, you can begin to genuinely do trial scenarios of historical data. So you can say, well, what if this happened? And instead of that being a boxed-in scenario, which is what happens today, you can do it using your historical data store. That would be awesome too. The data scientists would take your arm off for that stuff. And that was what we were looking for. That was where we went in. So what did we do? How did we set about answering the question of whether GPUs were a starter for this? Obviously, we wanted performance at scale. We've talked about the speed of the data and the volume of the data are both issues. We wanted to find out, because we want to understand performance, what a single host could do. Not interested in at this stage in saying, well, if I have a farm of 10,000 of these things, it'll do it. We just want to find out what one does. And most importantly, we had to use a business data set. We had to use something which was akin to what the systems are actually using. So that's what we did. We built ourselves a business data set. You'll see from the white paper, we built that in 3 different sizes. So we chose a desk size, we chose a line of business size, and we chose a firm-wide size. And then we multiplied that by a number of days. So for SQream, for example, they were able to run over, I think, 6 days of firm-wide data. So yeah. A mocked up scenario which was the size of more than a week of data for a big firm. And we developed a set of queries which began to exercise that data. Some of those were quite simple. We call them benchmark queries, not because they're doing any sort of form of repeatable benchmark, but because all they're actually doing is exercising quite simple SQL functions and seeing how fast they do that. So simple select, simple join, simple filtering. So we had a few of those, adding additional layers until we got to an understanding of how the systems were performing, and then some functional ones. So the scenario we took there was a trader blotter. So we wanted to imagine a trader who could see the risk that he was running in his book day on day. He wants to understand where that risk is coming from. So click, he can see here's all the trades. So there's a separate query that runs it. It has to return those trades. It has to return it in the time frame for a click. It has to be real time. And then he wants to see on an individual trade, where's that risk come from? What's the particular piece of market data or whatever it is that's caused that to be the shape that it's turning out? Click. There's a result again in real time. And we tried those on our different size data sets, and we tried them with all of the platforms that we were testing. That series of work was all really around fast, quick data that's coming at you fast. We did it with a static data set, but the intention is to be moving in a real-time world. So that's a replacement for the cubes in a real-time world. For the data scientists amongst us, with the bigger data world that we have there, we were looking at doing queries which would touch a lot of the data. So the particular query that we put together there was a moving average. And that's touching data which you cannot hold in memory. All the MapD and Kinetica and the fast data solutions hold all their data in memory. Now that's fine as long as you can get it into memory, into GPU memory. But if it's too big, as the big data scenario is, obviously that's not going to work anything like as well. So for the big data query that we gave to SQream, the challenge there was moving average over this enormous selection of trades over a period of a week or so. What are we seeing on screen? Hang on. Okay, so query 1 is to benchmark. We can see there that what stands out there is the performance of the GPU databases. We haven't put SQream on this one because SQream, as I'm sure you know if you're familiar with the company and with the product, does not play in the fast data space. SQream is about volume, about scale. It's not about performance at this sort of microsecond level for this real-time stuff. So we filtered out the SQream results. They just make the chart difficult to read on the others. So interactive data queries. Query 1 shows the sort of performance we can expect to see from the GPU databases, and I think you'll agree it's impressive. It's performant. David, could you go to the next slide? Query 3, similarly, interestingly, what we saw there, and we discussed this a little bit more in the white paper, is that SAP IQ, the slightly longer in the tooth solution, is actually good at, as the complexity rises, SAP IQ does better, which suggests to me a problem with, or a feature of maturity, if you like. We'll see when we come to the conclusions that the sweet spot for this type of use case, for this fast data use case, for GPUs is very much large denormalized data sets. Going into this, we were a bit bound by relational think. We didn't properly think through how to denormalize our data before we started, and I think if we had, we'd have seen a different set of results. There's definitely one of the things we could do to improve some of the results we got. But what you can see is that the more mature the application, the better it deals with complex queries. And so as we went up through the queries, each one becoming more complex, you saw better performance from the from SAP IQ. Can we go to the next slide, please? Okay. On the big data query, the SQream query, one of the impressive things about SQream in the work that we did was that we gave them all the queries. We didn't just give them the one. We gave them all the fast data queries too. And in fact, we gave them a couple of iterations of those because they didn't all work on all of the other platforms. We'd built them on a SQL engine, the queries. But when we tried them on some of the other platforms, there were issues. We had to go back and rework them. But they all worked on SQream. So actually, what I was saying earlier about maturity, one of the things that stood out about the SQream solution was that it seemed to handle the query complexity with aplomb. It seemed very capable in that regard. I'm sure David can talk to that himself at some point, but that was our experience anyway. We ran SQream against BigQuery. BigQuery obviously is a serverless offering, a cloud serverless offering. We might come back and talk a little more about those later. But what you can see here is that SQream, as the volumes went up, SQream got progressively better. In fact, I think if you go to the next slide, David. No, it's not there. Okay, sorry. There's another slide in the white paper, which shows that the performance of the two on a line chart, and you can see how as the volumes are increasing, SQream's actually doing better and better, which is exactly what SQream tell us it will do, and it was nice to see it borne out in reality. Okay, so the conclusions then, if you go to the next slide, please. So as I said earlier, the brute force solutions on denormalized large data sets seem to be a sweet spot for the GPUs. The more complexity, the more joins particularly that you put in, the less performance you get out of them from our experience of the sort of fast data use cases. But once you know that, actually the performance, the raw performance of these things is awesome. It's very incredible what they can do. Clearly in the SQream world, that performed BigQuery. We didn't have the time or the resources, unfortunately, to do a comparison with a Spark solution. That will be interesting. If we get time in the future, we might give that a go. But I think the SQream have demonstrated that they're capable in that space. There's actually one of the interesting things about the SQream solution was that it ran on a single GPU card and a single server. And the answer for SQream may not be about, I don't know how it's going to perform against maybe Spark or whatever, but cost-wise, they compress the data extraordinarily well, and they get an awful lot of bang for the buck out of the GPU, as far as I can see. So I think the cost basis alone for SQream is going to be worth consideration if you're looking at a big data solution. More broadly, the roadmap for GPUs is compelling at the moment. If you look at CPUs, they tend to be topping out. We're not seeing a great deal of Moore's law is not playing out on CPUs anymore, but we are seeing it on GPUs. That kind of growth is continuing, and we know that the GPU hardware that's going to be released even later on this year is going to be a step up from where we are today. So that looks like a strong solution going forward. Interestingly, there was nothing to pick between the cloud providers. We did all this on the cloud. So we used Amazon, we used Azure, and we used Google. But apart from some limitations in terms of how many GPUs you can get in the box, which are being, that's just an arms race. So the moment you do the test is you take the best you can get. And the others catch up pretty quickly. But there's we saw no competitive advantage from one vendor over another in this space. And I think the focus, if you're now looking at building a platform based on GPU technology, would be around that enterprise readiness. So obviously we're investment banking. We're looking at big firms that are literally betting the bank on technology. And so you've got to be confident that your platform is going to be able to perform, you're going to be able to manage it, control it, and so on. And those are probably some of the challenges that we're going to have to face as we move into these things. So the problems that we saw, challenges that we saw going through the testing process that we did, getting to the right scale. So you'll see from reading the paper that we had no way of knowing whether our data was all going to fit on one host or not for some of the platforms. Some cases it did, some cases it didn't. So we learned that by trial and error. There was no implementation guide that could give us any clues to that. There wasn't much in the way of tuning and tweaking guides. Again, I'm not on some of these things. So when we did see problems, it was sometimes difficult to work out what had happened and why. Understanding how the query plan had actually been put together and whether, based on that, whether you could reconstruct the query in a different way was sometimes difficult. I'm sure the tools are there, but it wasn't readily available. So there's just maturity problems and just things that you need to be aware of as you're thinking about what it means to implement these emerging technologies. And one of the biggest problems that we had, again, these tend not to apply to the SQream world because SQream did that testing themselves, but load times, loading data into these platforms takes an awfully long time, and that has to be solved, because if you're planning to load the results from your overnight compute batch for all of your investment bank into a GPU database for real-time queries, it's no good if it's going to take you 8 hours to make that load occur. It takes you all night to run the batch. It can't then take you another 8 hours to load it into the GPU solution. Now, I'm sure there are answers to all of those things, and I'm sure that scale, in terms of adding additional hosts, for example, will definitely help in some of those scenarios. But those were some of the things that we found ourselves bumping into as we did that testing. And so as we go on then to where does that take us? What conclusions? What sort of further analysis would we recommend if the banks were serious about going down this path now? I think the first one would be looking at streaming data. So as I said, we did this with static data sets. So and again, I'm talking here about the fast data arms race, really. So concurrent input and output, having data coming in at the rate it really does in a bank, where prices tick every second, and revaluations occur at the press of a button. We need that to be coming in at that rate, and for the user community to be able to query it back in near real time, so that they get a real and present and current view of their world. So that's one thing I would look at. I would definitely look at clustering. definitely, how do these things scale up and what impact does that have? There were some things we learned as we went through this process about how the data was being distributed and presented to the GPUs. And some of those things not even GPU specific. I know that some of the way the data sharding works on the GPU solutions is similar to the way it works in Microsoft's Cosmos DB, for example. It's not a problem, but you need to understand it, because you will not get the performance or the function that you need unless you've properly got your head around what data you can join to what using the sharding strategies that are available. Multi-user solutions. Again, we were doing this by running a query. That's not the same thing as having 20 or 200 or 1,000 users running queries. So something else I would look at would be how it will support multi-user scenarios. For the big data scenarios, SQream passed our test with flying colors. I think what I would like to see there, if I were now to implement this in an investment bank, would be a bigger data set. I mean, we went to 6 days. I think it was 5-6 terabytes, and the performance was fine. There was no problem with that at all. But let's see if we can break it. Let's see how high it can go. And also, we didn't get to go on and play with that ourselves. So I would like to see that interface then given to the data scientists so that they can try and run their SQL and make sure that the usability tools are there. Again, I have no reason to doubt it, but that would be my next step if I were asked to implement a SQream solution for an IB. And that usability interactive stuff is an ongoing theme as well for all of them, in terms of you want to be able to see ODBC, you want Tableau, you want all the nice interfaces that people are used to be able to get into this data. So that's something that again I would be looking to test and prove before committing to going down this route. And again, the ingestion problem needs to be looked at, and some improvements are needed there, I think. So that's a summary of what we did, and hopefully a summary of the nature of the problem that we're facing. So it's all about reading data. It's all about reading data fast and presenting that in a way that enables the different business units to work off the same data set. That's the solution that we'd like to be able to get to, and to give them the tools so that each of them can understand that data in a way that's most appropriate to them, but allow them to drill into the bits of it they need to make their job work properly, and to enable the banks then to use the scale of data that they create as a sort of first-class citizen, as an asset for the bank itself, which it should be. But which at the moment they're hindered from being able to do, because it's all buried into a variety of different technologies and different solutions, currently asset class aligned.
Well, Tim, thank you very, very much. That was a great overview. Is it okay if we take some questions that have come in?
Yeah, sure. Yeah.
Okay. So just to remind everyone, if you have a question, and we've received a couple, but if you have a question, please use the question panel located on the right side of your GoToWebinar panel, and we'll be taking the questions from there. So the first one came in from Vladi, and the question is, how commonplace are GPUs in other areas of financial data processing? It seems to me it would be a great fit for anomaly detection with machine learning or other areas of financial data processing.
Sure, that's a good question. So GPUs are not completely new technology in the world of finance. We talked about those risk platforms up at the asset class level, and there are some fairly well-established solutions there which use GPUs to run the Monte Carlo or analytic simulations that the banks are running. So definitely in that space, there are homegrown applications which the banks have written for themselves, and there are even vendor applications that incorporate GPUs. So Murex, for example, French product which offers investment banking services, that has GPU support. I also know of investment banks that are looking at the deep learning scenarios for GPUs as well. So in that case, for example, trying to identify records, which is a sort of key word, if you like. A record is a document of business interest, which is buried in an otherwise unstructured set of data. So if you imagine, searching through a vast sea of documents on a shared drive, trying to work out which ones of those are actually legal documents or in some way critical for your business. There are solutions being looked at there, which would use GPUs for deep learning to get the answers on those. So not new in finance, but I don't know of anyone currently actually running a live GPU database in finance, although I do know that the banks are looking.
Yeah, actually, we have a couple of implementations of SQream that we're working on with several banks, and I believe that that's something we'll be publicizing in the coming weeks and months as soon as we get permission from them to do so. So we do have some of those. Another question that came in is regarding the implementation itself, whether it should be on the cloud or on premise. Do you have a feel for that?
Yes, that's an excellent question. So three-part answer for that. First of all, as I said during the talk earlier, there's no particular competitive advantage between the clouds. So it doesn't matter whether you choose Google, Amazon, or Azure, you'll get more or less the same service from each. We weren't able to discern any difference. So pick your favorite and go. What I would say though, the cost model for GPUs in the cloud is not optimal for databases from the work that we have seen with the cloud providers that we were using. So it looks like they're pricing these services more for bursts of activity, presumably around machine learning, around deep learning, and they're priced accordingly. So the difference is if you have a GPU database, is a service you expect to be always on, and therefore you're not prepared to pay a premium for that. It needs to be at a reasonable baseline rate. What we see if you actually look at the cost of the hardware versus the charge out rate, you'll have paid for the hardware in about 18 months, I think, on the rates we're being charged by those big three providers. So I think if you're looking at implementing a GPU database, I would look seriously at that and wonder whether I should be building that on-prem. The final rider, though, is it's an excellent way. Cloud is an excellent way of doing a POC because it allows you to chop and change the solution that you're using. You might be uncertain, for example, whether a four-way VoltaBox is going to give you the performance you need, or whether you need an 8-way, or what the difference would be between them. It's one of the things we tested in the paper. You might be uncertain as to whether you needed a K80 or a V100. One has more memory, the other has more cores. Doing this in the cloud allows you to switch between those things and to make that experimentation a very short circuit loop, which you can do quickly and reasonably cheaply, and then decide what it is you want to implement. So I think there's definitely a case for using the cloud, definitely for these POC activities. I think doing those on-prem is expensive and difficult and kludgy. Doing them in the cloud is fantastic. But when you come to build the final end state solution, you need to look at the cost model.
Okay, excellent. So another question came in from Simon. Are there new technologies other than GPU being used to address these challenges that the banks are facing?
Interesting question. I guess the obvious one in the sort of fast data space. So there are two different categories of use case that we're looking at here, the big data and the fast data. In the fast data space, you would have to say that the streaming tech, which is being worked on these days, is a candidate for this. So I'm thinking here of solutions like Apache Flink and so on. Definitely candidates, definitely worth looking at. There are, obviously there's all the legacy applications, the in-memory pivot tables and so on that SQL Server Analytics Services provides, for example. That's all well known. It's not, I wouldn't say it was competitive. It doesn't scale. That's there's the sorts of problems that we're already seeing trying to use those. And we're seeing, I think, a bit of a change in the way that databases are evolving. I mean, for a long time, the big boys, the Oracles and IBMs, have had the field to themselves. And I think we're beginning to see a change to cloud providers for data warehousing. So whether it's BigQuery, whether it's Redshift, whether it's Cosmos, from the different cloud providers, these serverless offerings are coming in now. Now, I think in the white paper we can see that they don't necessarily perform the way that GPU databases do. So it's not a comparator on performance. But depending on the problem that you've got, depending on where your data is, that's another emerging tech which is worth keeping an eye on.
Right. So actually, the question came in, I guess it was in parallel to what we had talked about before. I'm just looking to see who it came in from Ben. And it was about what are the applications of GPU in commercial banks. And I just had a look at some of the things we've been working on. And one is similar to the stuff we were doing together, or that you had done in assessing the GPU databases in your white paper, which, by the way, I put it back on the screen because we went through it a bit quickly. So anybody who wants to download the white paper, and I highly recommend it, it's www.citihub.com, insights/whitepaper/GPU. So really, it's a very interesting read to go through the whole paper. So two of the areas that I know that we've been involved in have been also in risk assessment, and here we're talking more consolidated risk, and also in fraud reduction.
Yeah.
And I think some of what you refer to as the interactive data, they're looking at, as you said, more of the trading systems. So I think looking at the big data, we're looking at more of the trending for fraud reduction, money laundering, and things like that, and maybe risk assessment with historical data, and the interactive data applications more on the trading side. So there was another question came in, and I guess this was someone who isn't in banking, from Rajesh. So what are equivalent challenges being addressed in other verticals? And maybe Tim, I'll take that one if that's okay, and you can add to it if that's okay. Sure. So the primary challenges that we're seeing are that companies have been storing data for a long time. Enterprises have been storing data for a really long time, and sometimes they just don't use that data. And one of the reasons is because their systems that they have are, let's say, antiquated. And actually, the question was asked also about about SAP. It's an older system, and we've been seeing older systems like some of the MPPs, Teradata, Netezza, and others that the cost to upgrade and to try to handle 500 terabytes of data is pretty high, and so the trade-off is not always understood between, okay, so if I'm currently my queries are taking 5 hours or 2 days, and they used to take 2 weeks, maybe 5 hours is good, but people don't realize they can actually get their results in 5 minutes. And that 5 minutes might mean a different frequency of reports that are being given to management, or it might be, how much historical data you can actually look at. So I think here we're seeing in telecom that the operators are using their data, or starting to use their data for customer segmentation, personalization of products, location-based advertising, even network optimization, because they're able to look at the data that's coming in from the cell stations to prevent overload and to be able to give better quality of service. We're seeing it in retail. We're seeing in retail, for example, even one of our big customers in the United States, they're using the product there also for being able to look at more historical data of their customers, and actually being able to track and to uncover incidents almost before they happen, so that they can be proactive about handling things like issues with shipments, historical and geographical issues that arise based on the time of the year, the amount of people that are ordering, what kind of things they're ordering, and basically really doing a deep drill down into the data regarding customer preferences and things like that. So there again, it's again the ability to look at a lot of data, to get the queries done quickly, and to be able to provide the results very quickly. And of course, as Tim mentioned, the ability to ingest the data. That's critical, because you don't want to spend a month or even a week or 3 days or 4 days ingesting the data in order to reduce your queries from 5 hours to 5 minutes. You want to do a very quick ingest and be able to benefit from that data. So one of the other questions that came in was what was the size of the data used in the interactive data? And you had mentioned for the big data, it was 5 to 6 terabytes. So what was the size of the data on the interactive side, if you have that number available?
Yeah, sure. So we used we had a number of different data points. We had what we called in business terms a single desk, a line of business, and then enterprise and weekly for the enterprise. So the single desk was about 37 gigabytes. The line of business was about 100 gigabytes. The enterprise was about 600 gigabytes for a day. So each one of those represents a day's worth of activity. And then it's going up to, as I say, 5 to 6 gigabytes for, 5 to 6 terabytes for the weekly scenarios.
Okay, so if I recall, MapD, they were able to handle both of also the enterprise and also the, just going, if I go back, if I may.
Yeah, so there was one query that MapD really choked on, and on that one it wasn't able to handle the enterprise, but on everything else it was.
Okay, and Kinetica, I see here, is not in the enterprise. Okay, I understand. Yeah. Okay, excellent. So I think we've covered. Let me just check. Any other questions before we close? I think we've covered all the questions that have come in. Just giving a quick check here. Yeah, there was a question about SAP IQ, and the fact that it's legacy and how it compares against the GPUs. And I think we saw that in some queries they did okay.
Yeah.
And in some of them,
queries they were not good. Yeah.
Right. Okay. Great. Well, Tim, it's been a really, really informative session. We appreciate the fact that you were able to share that with us. And again, I recommend that everyone will download the white paper. Once again, www.citihub.com/insights/whitepapers/GPU. And if you have any closing words, Tim?
No, thank you everyone for attending today. I hope there was some value in that. Obviously, if you've got further questions, you're welcome to email either David or myself. I can be emailed at tim.jennings@citihub.com. David, I'm sure everyone must know your email address, I'm sure.
David@SQream.com, SQream.com. Excellent.
Yeah. Cool.
Okay.
So thank you very much. Thank you for the opportunity.
Okay, thank you, and look forward to seeing more of these reports. It really was an eye-opener, and we really enjoyed reading it. And thank you so much for doing it.
That's great. Thank you very much.
Okay. Take care, and thank you, everyone, and we'll see you at the next webinar that we'll be hosting next month. You'll all receive information about that. Have a good day and evening.